Okay, so we're beginning today, and for those of you that, there's Laura. Laura's back. Hello, everybody. The rest of you, you drama people, see how you are. Yeah, so we have today Alicia sitting in Sarah's chair, and we have Natasha sitting in Mikkel's chair. And ladies, I hate to be the bearers of bad news, but I don't think they're going to give them up. So you two are just kind of out of luck, I guess. Anyway, our two quick questions for the day. The names or formulas of the 6 strong acids. And strangely enough, we have 6 of you here today, so that works out very nicely. Let's start with you, Natasha. Pick one.
How to write it?
Certainly.
Okay.
Well, can we go up?
Actually, I was going to say that's between you and your English teacher, but yeah, go ahead.
May I write it?
You may.
Can we write like just the equations?
And hi to you too. That's hydroiodic acid. That's one of the 6. Next in line, Alicia. We're going this way, sorry. They're all good ones. There are no bad ones here. All right, hit it. Ooh, and what's it called?
Perchlorate. No.
Perchlorate is the ion. The acid is perchloric acid. Good. Okay. Laura.
Are we all doing different colors?
You can do whatever your little heart desires.
Okay.
Okay, now that's just weird. No, it looks good. What's it called?
Sulfuric acid.
Sulfuric acid, H2SO4. Okay?
I got a good one. How many members of the USS Enterprise does it take to change a light bulb? 6. Scotty to get on the intercom when the light goes out and say, "I cannot do it, Captain." Spock to tell Kirk he is proceeding illogically. McCoy to say, "Damn it, Jim, I'm a doctor, not an electrician." Kirk to screw it in, and 2 red shirt security officers to die in the process.
This is true. All right, McKay, what have you got there?
Hydrochloric acid.
Hydrochloric acid. Excellent. So, Kyle, I guess that means you're next.
Dang it. Hopefully he doesn't take more on.
And that is?
Nitric acid.
Nitric acid. Good. So we've got the last one. No pressure, of course. And that is?
Hydrobromic.
Hydrobromic acid. Good. I am encouraged. From our conversation last time, why isn't HF on this list? Electronegativity. Fluorine is so electronegative it holds on to the hydrogen harder and it can't dissociate completely. Excellent. Now write the equation for the dissociation of formic acid, HCO2H in water. Identify the conjugate acid and conjugate base, and name the conjugate base. So this will take us back a little bit. So, dissociation of formic acid and water is going to start with formic acid, HCO2H, plus H2O. And we typically write these dissociations as an equilibrium reaction. What are the products? Hydronium ion's got to be one of them. Okay? So H3O plus is 1. So, where does that third H come from? Because we have an H2O from here. Where's the third H come from?
Acid.
Which one specifically? The one attached to the oxygen. This is the acidic proton. That's the one that's going to come off. So, what do we have left then?
I thought that cation would just be first, so I couldn't. I mean, if it's H plus coming off, it would be the first one. Is it just with oxyacids it does that?
Yeah, remember we said last time with the oxyacids, the hydrogen that comes off is attached to an oxygen.
What about like perchloric acid? Is that hydrogen attached to an oxygen?
Yeah, it is.
Then why don't we write that on the end?
HClO4.
Like ClO4H.
Yeah, we could do it that way. We're kind of in between conventions here. On the one hand, we know that if we drew out this structure, which would look like this, we know that the one that comes off is this one. And by the way we've written this, it kind of implies that it's that one. On the other hand, the convention for writing the formula for an acid is H and then whatever the ion is. So we could say that that what's left over after this is CO2H, which would be the same thing as HCO2. I guess I just emphasize that this one comes off because it's the one that's attached to the hydrogen. Okay, the oxygen.
So you could say the other one came off and just really.
You could. If I were asking you to draw the structure and to identify which one came off, you'd know that it had to be the one that's attached to the oxygen. Okay, one way or the other though, what's left over after a hydrogen comes off here? HCO2 or CO2H. Okay? Here, we'll write it this way if it helps. CO2H minus. How's that? Okay? So we had to identify some things here. What is the conjugate acid? First of all, what's the definition of a conjugate acid?
The base after the sheet.
Right, it's whatever has the additional hydrogen on it now. What has the additional hydrogen now?
Whatever it's called.
Hydronium, okay? So this is the conjugate acid. What is the conjugate base?
CO2.
It's whatever's left over after the hydrogen is lost, so it's this one. This is the conjugate base. What is this ion called? Think about how you name acids. Work backwards to get the name of the ion. What's the name of that ion? Did you know it, Alicia?
Well, I have a guess.
Take your guess.
Probably not right. Hydrogen carbonate, but then I was not trying to account for the ion.
It's not hydrogen carbonate, sadly.
Okay, that's why it was a guess.
Think about the name of the acid. What's the name of this acid? So, there's your ic acid. What's the name of the ion? Formate. This is formate ion. No, but you should know the system. You should have memorized the system. If it ends in ic acid, it becomes 8 when you're looking at just the ion. All right, so far so good? All right. Excuse me.